Hello and welcome. Today, actually, I'm going to give you some hints for Unit 3 assignments. Now, first of all, guys, this is not a lecture, so you have to read the book and the slides first, otherwise this will make no sense. So question number 1, this is about the normal distribution, the bell-shaped curve. Right here, mu, and then we have mu plus sigma, and then mu plus 2 sigma, and 3 sigma, like that. And to the left, mu minus, and mu minus. And mu minus 3 sigma. Now there are some values. So between these certain number 64, 65, and sorry, between mu minus sigma and this, and then between this, and then between this, like that. That question is asking you about that. Now in your slides, I think that's in slide number 6.1. Yeah. So maybe not that. So somewhere here it should be. So for a normal curve, we have that idea. So this question is based from that. Anyway, let me go to, give me a second here. Yep. No, here, see, slide 6, sorry, slide 6.2, yeah, 6.2. See this particular slide that you are watching now, 68 of the area between -1 and 1, 95 between negative. That means, see, this is the normal distribution. So this is 68, I'm sorry. Now, standard normal distribution, actually we assign the same thing, right? Same idea, but here this value we assign it 0 because our z value, the z score, that's going to be 0, and to the left these are going to be negative numbers, to the right these are going to be positive numbers. So the formula is z equals rho square x minus mu, and then divide by sigma. I think that is addressed in our next set of questions in next assignment. Now that's question number 1. And so let's see, to the right of mu, that's actually straightforward. To the right of mu, that's 50%, right? 50% to the right of mu. And between mu and mu minus 2 sigma, mu plus 2 sigma, that is from this value, that the value that I showed you earlier in the slide. So it's straightforward in this figure. So that's that value. And then you have to the, let me see, to the right of mu plus 3 sigma. So to the right, that means this one, that small value, that's going to be very small value. So how do you calculate that? So let me show you again this. Now you know between, look at this slide, between -3 and +3 z value, or that means mu minus 3 sigma, mu plus 3 sigma, between that 99.7. So that means a lot, right? So between -3, that means mu minus 3 sigma, positive 3 plus 3 sigma. Between that, this area, that is 99.7. The total area is 1. So the remaining part, let me use a different color. Remaining part is this. Question is asking you only this. So figure that out, okay? And this this curve is symmetric, so it plays a role. Now I have almost told you the answer. Cannot do more. Okay. Oops, sorry about that. Second one, vending machine. Now read, you can pause the video and read it. So this is about actually, again, first one, overflow 8 ounce cup. So let me explain now. Still, that depends on this one. So it's telling you mean 7.6, standard deviation 0.4. Now guys, these numbers are important. Mean 7.6. So here 7.6 and standard deviation is 0.4. So mu plus sigma, what is that value is going to be? 7 plus 6, 0.4. So 8, right? So it's not an accident that you see the number 8 here, because without using Z tables, you can easily answer this question just by basic knowledge. So this point is 8. The question is asking what are the chances that it will overflow. So you are looking at that area. So figure that out. And estimate the probability machine will not overflow. So 1 minus your answer in part A. So if you got, for example, 30%, for the part B is going to be 70%. Okay, part C, the machine has just loaded with 850. Actually, there's again, there are typos in these questions. These cups, you have to assume actually these cups are 8 ounces. 8 ounce cups. So how many of these will you expect to overflow? I mean, that's pretty easy because, for example, for part A, if you got, let's say, 20%, so part C, it's going to be 20% out of 850. Find it. So as you can see, the key is to get part A correct. Part B is going to be 1 minus that. Part C is going to be 850 into whatever you answer in part A, right? Okay, now question number 3. Now let's see, what is this? Okay, these are about those control charts. But this is not that hard. Now let's say day number 1. Again, read the question first, guys. So day number, I don't know why this. Okay, now it looks clear. So day number, we have 10 days. So what you need to do, these control charts. Okay, you have to create 1, 2, 3. Again, the best way to do this is read the slides. If you have time, the whole book. I mean, this is a fast moving course. So slides are pretty good, and you can find similar questions in the slides. So that will be really helpful. And the number of visitors, right? So you see 25, 19. What is the lowest? I see 15, and what's the largest? 30. So you have to pick the lowest and largest and then make some scale. So it was 15. So let's go with, just to be 10, 15. Go a little less so it is clear. 25, 30. And I don't need that much. And then what you need to do, you can complete this whole thing. Sorry about that. So this is the chart actually. So now, again, please, there are a set of rules in the slide. So read them. Something you want to do here, find out the average, the mean 21.7. So in your 21.7, roughly, right, somewhere here, and then simply put the dots So see, day number 1, 25, day number 2, 19 and 17. So 25, 19, 17, 25 somewhere here, 19 somewhere here, 17 somewhere here, like that. Complete this. That is simply it, part A. Part B, same story. And now in control, now out of in order to do that, you have to understand what is meant by out of control. For there are several criteria. Now let me show you. That should be here in 6.1. See, out of control signal, there are 7 criteria, I think. First one is 1.4 beyond 3 sigma level. That means, guys, now this is mu, right? And then if you draw mu plus sigma, mu plus 2 sigma, mu plus 3 sigma, if one of them is going out of mu plus 3 sigma, that is out of control. So not in control. That's criteria 1. And you have criteria 2, read these again, and criteria 3 and all those things. Actually there are 4, not 7. So a run of 9 consecutive points on one side. And so basically it's about, I think, first one, if it is more than or less than 3. So for example here, see, these 2 red dots are away from the in control zone. So I think now it's clear, right? You can answer easily that question. Now let's go to 3.2. Now this one basically depend on the, see, again, pause the video and read it. I mean, always watch these videos after trying and after reading, right? Otherwise it will make no sense. You have to know something, because again, this is not teaching. This is not teaching. I'm just giving you hints. Now to find z-scores, well, I think I already explained this. So the relation between z-score and rho score. So this is z-score, the letter Z is C. This is rho score. X minus mu divided by standard deviation. So it's straightforward. In part A and B, you have to find z-score. That means you know this, you know this, you know this. Figure that out. In part C and D, you have to find the rho score. So again, the same formula. Now you know this, know this, know this, but you have to find that, part C and D. That's pretty easy algebra. Now, question number 2. Find Z such that 5.2 to the left. Now, what does this mean? Again, we are dealing with our usual one. Now, let me explain. 5.2 to the left. So, you have to find some value. See, for example, this C value right here is 0. Well, these are pretty straightforward stuff. Like, you have to understand, I mean, why? Because that's the mean, right? If you apply that one, you'll get z-score 0. Now in the standard normal deviation, this point is 0. So everything to the left is negatives. Everything to the right, those z values are positives. Now 50% of to the left, 50% to the right. Now it's only asking you to find 5.2%. That means first you have to convert this into decimal numbers, divide by 100. So 2 more. 0.052. This is the value you are looking for. Now this one, so that means if you think about this carefully, 0.052. Now this area is 0.5, half of it, right? So 0.05 is like 1/10 of that. So the value you are looking for somewhere here. That's going to be a negative C value. But this is still the same question, same story like this. But see here 68, here 90 something, 99.7. You don't have nice numbers throughout. So now you have a table. So that's the idea. In order to answer this question, now you need to find this in the C table. Now where do you find that? Well, you have to have the book. Let me see. I don't have the physical book. I have this here. So you have to go, let me see, I think I opened it. And then scroll down to tables. And then, not table 5, if my memory is correct, table 5. Table 4, a little bit more. Come on, table 5. See, now at first it was not. See, you can do this if you want to read this clearly. For me, the book seems a little bit blur. Now these middle values, those are the values. So you are looking for C 0 point C. Let's see, 0.052. So those middle values on your table are the area. So you have to find that. So let's see, 0.052. Where? Well, now you have to look at the cursor, 0.0505. Well, see 1.7, 1.6, sorry, negative 1.6, you have that. So 0.052, you see it here, and that's 0.0526, little bit more than what we want, 0.0516. Which one is closer? So it's actually a value between these two. But what is that C value? How do you find that? That C value is negative 1.6. Not just that, now you have to go to the column heading. And 0.26 is under 0.02. And you know what, let me. So if I negative 1.6 under, what was it? 0.02 and 0.03. 0.02 and 0.03. The value we are looking for is between these two values. So the actual C value is going to be somewhere here. That means negative 1.6 to 5 or something like that. That would be a much closer answer, but it's still negative 1.63 and 62 are good answers. But negative 1.63 is much better because, see, negative 1.63 is right here. How do you get negative 1.63? Negative 1.6 from this and then 3 from that. So negative 1.63 is, see, 516 is much closer to 5.2 than 5.26. But you know, using some algebra, you can find the actual value. I mean, not actual, much closer value, but any of these will. See, I already did that question for you. So the same idea for part B. Think carefully because it's 99.7. So how do you find? There are two ways of finding that actually. Because now let me give you the idea. So 99, 90 something. So you are looking for some big value right here. For that 99, you can convert that to 0.9 something and do the same thing that we did. Or you can do 1 minus and find this value and convert it into minus, and because see, this is symmetry, right? Because of that symmetry, it's always works well. Okay, anyway, number 3, well, read the question. It's pretty well, there are two sets of information. First read it, right? But it's not that hard again, but there is, you know, there are some typos. So convert both x1 and x2 values to C values and then locate well, that's all you need to do. So forget about this part. And then using that, you for this one, what you need to do is compare that with mu1 and mu2. So compare mu1 and mu2, and which one is far away, that's going to be unusual. That's not that hard. So that's 3.2. Let's go to 3.3. Now 3.3, in this one, let's say 5-number summary and create histogram. Now histogram is pretty easy. You had 6.8 to 7.2, so you 6.8 to 7.2. What was the next? 7.2 to 7.6, 7.2 to 7.6. So in a good scale, you have to keep doing that. And then this direction are the frequencies, 21, 73. So 21, if 21 is something like that, 73 is, so 3y as that, and 100. And so good scale, right? Make it into a good scale. I'm just drawing it. I'm giving you some hints. And you complete that. That is the histogram. And mound shape, well, is it roughly this shape? Figure that out. And then interquartile range, part B, IQR. Interquartile range, that one is nothing but Q3 minus Q1. So figure that out. And then it talks about outliers. Well, lower fence, not let me recall you. Lower fence, you calculate lower fence. Well, you find this value IQR. So lower fence is Q1 minus 1.5 IQR. Upper fence is Q3 plus 1.5 IQR. Now, what this means is, see, you have Q3 here, Q1 here, and you found some value. So you go a little bit further, Q1 minus and Q1 plus this interval. If your data lies somewhere outside that interval, that's an outlier. So figure that out. Yeah, again, we have, some statement wise, that is explaining what I just explained here, this whole story, but there are some typos in words. Now, Pearson index, and that is, I think, let me see, Pearson index was somewhere. Nope. Maybe 6.3. No, let me see, maybe here. Yeah, see, Pearson index. So that is 3. The formula for Pearson index is actually 3 times x bar minus median divided by S. So again, looking at this example would be easy for you to, would be helpful. Now, number 2, that's about sampling distribution, guys. Now, number 2, again, there is a mistake. Here it should be X bar distribution. So X bar distribution, not X distribution. And well, X bar distribution is going to be approximately same as X distribution. And then you have to find the mean and standard deviation of that. So let me recall you again. You have to read this stuff first, right? Otherwise, this will not make sense. So mu of X bar distribution is same as mu in this case, and standard deviation of X bar distribution is this. This is the formula, and the related stuff. Oops, is somewhere. Oops. Yeah, somewhere here. See, there are examples like that. Now you can work them before doing your actual And part B, find Z value corresponding to X bar. Now, this is again the same story, converting between Z and Z score and rho score. Remember this formula, but now for the sampling distribution, so your C is actually X bar minus mu X bar minus sigma X bar, right? You already know this from part A. And part C, find P X bar greater than C. Again, this is X bar. X bar, so X bar greater than 9. So P X bar greater than 9. P X bar greater than 9. Now, the easiest way to do this, you already know X bar, from part B, you know the Z value. So you can write this as P Z greater than whatever you find in part B. What was it? Part B, yes. And then if that was a nice value, for example, let's say it was 0.5. If that was 0.5, well, it's pretty easy because that's going to be 50%, right? But if there is a number, not nice number, you have to use the Z tables. I think the idea is clear, right? Part C, would it be unusual? Well, that depends on your answer on part C. Because, for example, if you had very low, like 0.0003, yes, that's unusual. But if you get like 40%, 30%, well, it's not unusual. Now, last question. Well, that's sampling error. Well, let me, the video is becoming larger, so let me quickly address this. See, sampling errors, standard error, see, it again completely depend on this equation. So I think that's enough for today, guys. See you in next unit. Thank you.